My name is Romeo Zendejas.
Hi, my name is George Peralta.
Hi, my name is David Zamora.
Hi, my name is Ines and we're doing the Andes Mountains.
The Andes Mountains, like many other mountain ranges, were formed by plate tectonics, and the oceanic plate called the Nazca Plate moved towards the east and then collided with the South American plate. The Nazca Plate lifted the South American plate by going under the landmass above it, and then in turn, this created the mountain range. This process is more formally known as subduction, and in subduction, two plates collide at their convergent boundary, which then causes one plate to move under the other, in turn creating um, mountain ranges above it. New research, however, has suggested that the mountain range was maybe formed through a series of periodic rapid pulses instead of a gradual uplift of the surface. More specifically, this means that the range is thought to have risen at least 1 kilometer over several million years.
The Andes Mountains began to form during the Cenozoic era approximately 65 million years ago. Many scientists throughout the years have speculated over the age of the mountain range, as different methods would often give different results. But as time progresses and newer technologies are made available, better dates have been ascertained. The Andes Mountains are primarily made of two igneous rocks, andesite and dacite. Andesite is a fine-grained igneous rock material that is composed in the Earth's crust. It is produced when magma erupts on the surface and cools quickly. Dacite is also a fine-grained material that is similar to andesite, but contains fewer. It contains a few more large crystals known as phenocryst. This lends to dacite being more porphyritic than andesite.
Many of the rocks found in the Andes Mountains tell us about their age and the formation of these mountains. For instance, the ancient granitic continental fragment, which makes up much of the sediment found in Brazil, is ancient and has risen from its original deposit. It was deposited between 450 and 250 million years ago and consisted of sandstone, siltstone, and limestone that transformed respectively into quartzite, shale, and marble. This transformation was caused by the downwarping of the crust with its pressure and heat. It wasn't until the formation events occurred that the material would be uplifted and be evidence of the events that occurred.
So why is this site important in interpreting human and geologic history? So the evolution of the topography of the Andes Mountains provides geologists with really important information about geologic processes over time. And since the topography of the mountain range influences the way air is moved as well as our global climate, scientists can better understand and predict atmospheric patterns. And the climate in the Andes is also really interesting because it varies drastically within short distances. So, next to a snow covered peak called Cotopaxi, there are rainforests, and while the southern section is consistently rainy and cold, and the northern section is always warm, the central part of the Andes remains dry. And it's thought that the decrease in rainfall caused by the drying of the west coast of South America reduced the amount of sediment in the underwater plate, which rose up the Andes. And this is really important because it helps us understand the relationship between atmospheric conditions and geologic processes over time. Um, and a cool fact about the Andes is that it has the world's highest volcano called Ojos del Salado, which is 22,615 feet. So, yeah.
All right, so that has been our presentation, and these are our sources.
Nice.
All right, there we go.